Good morning. Today we have to see one more topic or one more point. Ampere's law of magnetic field. Ampere's law of magnetic field. Suppose this one as a closed loop. Suppose this one as a closed loop carrying current I. Then this current produces magnetic field. Suppose this one as a closed path carrying current which produces magnetic field around it. Then according to this law, the line integral of magnetic field, the line integral of magnetic field around closed path, the line integral of magnetic field around closed path, that is line integral like this, B dot dr. This is called as magnetic field. Line integral of magnetic field around closed path is equal to mu naught times mu naught permeability of free space. Mu naught permeability of free space, mu naught times current flowing through that closed path, where mu naught is permeability of free space. Statement परत एकदा बघा कसं केलं आपण. The line integral of magnetic field, the line integral of magnetic field around closed path, म्हणजेच हा जो क्लोज्ड पाथ आहे याचं मॅग्नेटिक फील्ड, the line integral of magnetic field around closed path, that is line integral B dot dr is equal to mu naught times current flowing through that closed path. Now we have to see proof. Statement. हे झालं त्याचं स्टेटमेंट. What is Ampere's law? The line integral of magnetic field, the line integral of magnetic field around any closed path is equal to mu naught times current flowing through that closed path. आता याचा प्रूफ बघा. प्रूफ. Consider 4 straight current carrying conductors. Consider 4 straight current carrying conductors like this. Consider 4 straight current carrying conductors carrying current, suppose I1, I2, I3, suppose I4. Consider 4 current carrying straight conductors carrying current I1, I2, I3, I4, in which currents I1, I2, I3 are within closed loop. समजा हे एखादा आपण क्लोज्ड लूप कन्सिडर केलं, and conductor I4 or current I4 is outside of loop. आपण काय कन्सिडर करतोय पहा, consider 4 straight current carrying conductors carrying currents I1, I2, I3, I4 in which now consider a closed loop or consider a closed path such that currents I1, I2, I3 are within path and I4 is outside path. Suppose that currents directed perpendicular to plane outside, currents directed perpendicular to plane outsides are considered as positive and that currents are inside plane are considered as negative. म्हणजे जे बाहेर आहेत ते पॉझिटिव्ह, जे आत आहेत ते निगेटिव्ह. Also current outside, magnetic field due to current outside loop is practically zero and therefore resultant current, that is I is equal to half plus I1 minus I2 plus I3. This is resultant current flows through conductors. परत एकदा बघा आपण काय म्हणतो या ठिकाणी. Consider 4 straight current carrying conductors carrying currents I1, I2, I3 and I4. Now suppose that currents I1, I2, I3 are within loop and I4 is outside loop. These currents are perpendicular to plane. These conductors are perpendicular to plane of loop. Sign conventions. The currents outside plane are considered as positive and that currents inside plane are considered as negative. Also currents outside loop is practically zero and hence resultant current I is equal to I1 minus I2 plus I3. Okay. Now according to Biot-Savart law, according to Biot-Savart law, magnetic field inside loop, magnetic field inside loop due to this current, that is B is equal to mu naught I divided by 2 pi r, where r be the radius of loop, r be the radius of loop. Magnetic field due to Ampere loop, but magnetic field due to Ampere loop and therefore magnetic field due to Ampere loop that is line integral of B dot dl is equal to B into dl into cos theta but magnetic field and length of conductor, dl, length of conductor are radius of coil, but length of conductor is along direction of magnetic field, and therefore theta is equal to 0, which implies cos theta is equal to 1. Magnetic field is along length of conductor, and therefore theta is equal to 0, which implies cos theta is equal to 1. And therefore line integral of closed, that is B dot dl is equal to closed interval P into dl. Value of B, that is closed interval mu naught I divided by 2 pi r into dl, which is equal to mu naught I divided by 2 pi r into closed interval dl. dl length of small element, dl length of small element, integral means total length of element, which is equal to circumference. dl length of small element, integral total length, which is circumference, that is mu naught I divided by 2 pi r into 2 pi r. 2 pi r like 2 pi cancel, we get closed interval P dot dl is equal to mu naught I. This proof our Ampere's law. हा क्वेश्चन स्टेट अँड प्रूव्हला विचारला जातो. स्टेट अँड प्रूव्ह एम्पियर्स लॉ. परत एकदा 2 मिनिटांमध्ये बघा. व्हॉट इज एम्पियर्स लॉ? द लाइन इंटीग्रल ऑफ मैग्नेटिक फील्ड अराउंड एनी क्लोज्ड पाथ is equal to mu naught times mu naught permeability of free space, mu naught times total current flowing through that closed path. Proof. Consider 4 straight current carrying conductors carrying currents I1, I2, I3, I4 such that conductors means currents I1, I2, I3 are within loop, within closed path, and I4 is out of path. For simplicity, currents outside plane are considered as positive, currents inward plane are considered as negative, and hence resultant current is like this. Now, according to Biot-Savart law, magnetic field due to current carrying coil, magnetic field due to current carrying circular coil, mu naught I divided by 2 pi r, where r radius of coil. Therefore, magnetic field due to Ampere's loop, आता आपण हे एम्पियर लूप घेतोय. काय आहे? B dot dl, dot product म्हणजेच B into dl cos theta, but magnetic field is along length of conductor and therefore angle between them is 0, that is cos theta is equal to 1. राहिलं हे B ची व्हॅल्यू आपण इथे सबस्टिट्यूट केली. हा टोटल कॉन्स्टंट आहे, त्याला बाहेर काढलं. इंटिग्रेशन ऑफ dl लेंथ ऑफ स्मॉल एलिमेंट, इंटिग्रेशन टोटल लेंथ मीन्स सर्कम्फरन्स, याला हे कॅन्सल राहिलं म्यू नॉट I. दिस इज अबाउट प्रूफ ऑफ Ampere's law. Now we have to see one more term, one more expression. Magnetic field of solenoid एकाच वेळी मी दोन्ही भाग घेतोय. मॅग्नेटिक फील्ड ऑफ अ सोलेनॉइड अँड मॅग्नेटिक फील्ड अलॉंग ॲक्सिस ऑफ टोरॉइड. बघा, magnetic field of solenoid, magnetic field of a solenoid. What is solenoid? Solenoid is a long, closely wound helical loop of conducting wire such that its length is very large as comparatively its diameter. म्हणजे सर्वसाधारणपणे सोलेनॉइड हा असा असतो. सर्वसाधारणपणे सोलेनॉइड हा या पद्धतीने असतो. सर्वसाधारणपणे सोलेनॉइड हा असा असतो. ह्याला म्हणतात सोलेनॉइड. व्हॉट इज सोलेनॉइड? अ लॉंग, क्लोजली वाउंड, a long, closely wound helical loop of conducting wire such that its length is very large as comparatively its diameter. म्हणजे डायमीटरच्या कंपॅरेटिव्हली ही लेंथ फार जास्त असते. ह्याला म्हणतात सोलेनॉइड. व्हॉट इज सोलेनॉइड? Solenoid is a long, closely wound helical loop of conducting wire such that its length is very large as compared to its diameter. Now, consider a solenoid carrying current. Suppose this one as a हा solenoid मी इथे दाखवतोय. Consider a solenoid. Consider a solenoid. Consider a solenoid. Consider a solenoid like this. खर तर हे जे पॉइंट्स आहेत, खर तर हे सर्व पॉइंट्स काय आहेत तर ते कॉइल आहेत. अशा ह्या सर्व अशा कॉइल्स आहेत या ठिकाणी. या पद्धतीनं then magnetic field is developed along this direction. Magnetic field is along this direction. Like this. Here we consider an Amperean loop. Here we consider an Amperean loop like this. Suppose this one as Amperean loop. Suppose this one as Amperean loop. आता लूपला नाव द्या तिथं A, B, C, D. This is Amperean loop. See once more. Consider a solenoid carrying current. density of magnetic field lines along axis within and at certain distance outside uniform. The density is very large within solenoid as comparatively outside solenoid. Suppose this one as a solenoid carrying current, then density of magnetic field within solenoid, which is represented by magnetic lines, is very large as comparatively magnetic field density outside solenoid. म्हणजे सोलोनॉइडच्या आत मॅग्नेटिक फील्डची डेन्सिटी जास्त असते, सोलोनॉइडच्या बाहेर कमी असते. मॅग्नेटिक फील्ड डेन्सिटी within solenoid is very large as comparatively magnetic field density outside solenoid, which is represented by lines along axis. Let L, that is length of solenoid, small n, number of turns per unit length, म्हणजेच एका युनिट लेंथ मध्ये किती टर्न्स आहेत, नंबर ऑफ टर्न्स पर युनिट लेंथ, I current flowing through that solenoid, dl length of small element of circular path. टर्म कोणकोणते आलेत, L length of solenoid, small n number of turns per unit length, I current flowing through solenoid, dl length of small element of solenoid. Then according to Ampere's law, line integral of magnetic induction P dot dl is equal to mu naught n I, n that is number of turns per unit length, किंवा फार तरी तर n म्हणतो, that number of turns n into n, which is equal to mu naught n l I. Suppose this is equation number 1. समजा एकच लूप असेल तर mu naught I, number of turns n, and therefore total magnetic field mu naught n l I. But total magnetic field that is equal to magnetic field from A to B plus magnetic field from B to C plus magnetic field from C to D plus magnetic field from D to A. हे सर्व इथं B dot dl, B dot dl, B dot dl, B dot dl. As sides AD and BC are perpendicular to field, as sides AD and BC are perpendicular to field, their line integrals are 0, and DC is outside loop, therefore magnetic field outside loop is also practically is equal to 0, and therefore we can write line integral from P dot dl from only A to B plus 0 plus 0 plus 0, which is equal to B into L. Suppose this is equation number 2. From equations 1 and 2, B into L is equal to mu naught n I L. L cancel, and therefore magnetic induction or magnetic field of solenoid P is equal to mu naught n I. This is an expression for magnetic field due to solenoid. जसं सोलेनॉइड आहे त्याच पद्धतीनं आता इथं पाहतोय मॅग्नेटिक फील्ड अलॉंग ऍक्सिस ऑफ टोराइड. मॅग्नेटिक फील्ड along axis of toroid, TORIOD. Magnetic field along axis of toroid. What is toroid? A solenoid. हा पण solenoidच आहे. A solenoid of infinite length bend into hollow circular tube. म्हणजे हा जो सोलेनॉइड आहे तो काय करतोय, आपण या पद्धतीने असा बेंड करतोय. ह्याला म्हणतात टोरॉइड. ह्याला म्हणतात टोरॉइड. लाईक दिस. अ सोलेनॉइड बेंड in the form of circle is called as toroid. A solenoid bend in the form of circle is called as toroid. This is axis of toroid. R suppose radius. Let I current flowing through toroid. R radius of circle. L length of toroid. N number of loops or number of turns. Then number of turns per unit length, that is number of turns divided by length. Total length, that is 2 pi r. Total length 2 pi r. And therefore, according to Ampere's law, line integral of magnetic induction P dot dl, जसं इथे केलं तसंच mu naught into n I. Suppose this is equation number 1. But line integral of closed B dot dl is equal to integral of B into dl into cos theta, but cos theta is equal to 1, and therefore B into 2 pi r. Total length 2 pi r. Suppose this is equation number 2. जसं इथे केलंय तसंच इथं. From these two equations, from equations 1 and 2, B into 2 pi r is equal to mu naught n I. Therefore, B is equal to mu naught into n divided by 2 pi r into I. हा 2 pi r खाली येतला, but n divided by 2 pi, number of turns per unit circumference, that is small n, and therefore B is equal to mu naught n I. परत पहा काय केलं. I current flowing through toroid, R radius of toroid, n number of turns, therefore small n number of turns per unit length. He total length circumference per unit length. According to Ampere's law, line integral is mu naught times I, number of turns n. But B dot dl, B into dl cos theta. Length of element is, or length of toroid is along magnetic field. Therefore theta is equal to 0. cos theta 1 म्हणजे याची व्हॅल्यू झाली 1. राहिलं B. Total length 2 pi r. कम्पेअर दिस टू इक्वेशन्स. 2πr ला इथं खाली घेतलं. n divided by 2πr is nothing but small n, number of turns per unit length, and therefore B is equal to mu naught Ni. This is magnetic field along solenoid, magnetic field along toroid. दोघांचा फॉर्म्युला सेम आहे. magnetic field along solenoid mu naught Ni, magnetic field along axis of toroid mu naught Ni. हिथं पण नंबर ऑफ टर्न्स पर युनिट लेंथ, हिथं पण नंबर ऑफ टर्न्स पर युनिट लेंथ. I करंट. दिस इज अबाउट एम्पियर्स लॉ. काय काय पाहिलं आपण? एम्पियर्स लॉ. हिथं एम्पियर्स लॉ, त्याचा प्रूफ, त्यानंतर मॅग्नेटिक फील्ड ऑफ अ सोलेनॉइड अलॉंग इट्स ऍक्सिस, मॅग्नेटिक फील्ड अलॉंग ऍक्सिस ऑफ टोरॉइड. दोघांचा तोच फॉर्म्युला आहे. ओके. तर या ठिकाणी हा जो तुमचा 10th टॉपिक आहे, मॅग्नेटिक फील्ड्स ड्यू टू इलेक्ट्रिक करंट्स, हा टॉपिक आपला पूर्ण होतोय. नेक्स्ट टॉपिक ऑन नेक्स्ट पिरियड. ओके.